All right, guys, welcome back. I had a great time seeing you guys the other day. It was a lot of fun. It's something different, something new. So we're back to the videos today. We're going to kind of expand upon what we did the other day, although we're not going to be quite jumping into that stuff, using that stuff quite yet. What we're going to be learning about is triangles and sines and cosines and tangents of triangles in the XY plane. Exciting stuff. So let's jump right into it. Okay. So what I have for you, you can see on my screen here. Yours might be just black and a gray. If you don't have a color printer, I have a red triangle and I have a green triangle. Okay. What I want to do is come up with our 6 trig functions for each triangle. So let's take a look at the red one first. I'm going to call that angle theta. Notice that that angle would be in standard position. Okay, and notice that this point here is 4, 3. And if I'm starting, if this point there is 0, 0, if the point is 4, 3, that must mean that the length of this side of the triangle is 4, and you can clearly see by counting the boxes it's 4. This side must be 3. And by using the Pythagorean theorem, I can find out that the hypotenuse is 5, right? That's a special Pythag triple, the 3, 4, 5, right? So in this case, if I asked you, hey, what's sine of theta of that triangle? You would say, well, sine is opposite over hypotenuse. Sine of theta is 3 over 5. Okay? If I asked you secant of theta, remember, secant of theta is the reciprocal of cosine. Cosine would be 4 over 5, so secant would be 5 over 4. And then maybe what if I asked you tangent of theta? Okay, well, tangent of theta is opposite leg over adjacent leg. That would be 3/4. Notice all of these values are positive. Okay, and since sine is just the reciprocal of cosecant, and secant is just the reciprocal of cosine, and tangent is just the reciprocal of cotangent, what could you tell me about the positive negativeness of all 6 trig ratios for this triangle? They would all be positive, right? All 6 trig ratios positive, right? They would all have to be positive because every part of that triangle is positive, right? I'm in quadrant 1. This is where it gets a little bit more interesting. So that's hopefully pretty straightforward. What if I came to that green triangle, the triangle on the left? What is point E right here? Point E is really -4, -3. So really, what would the length, or what would that leg of that triangle would be? It would really be -4, because really I went to the left -4, and I went down -3. So interesting. We're going to call that angle theta. Sorry, I should have made a right angle for each of these. Right, those are altitudes dropping down. Okay, so interesting. I have side lengths of -4 and -3. But, however, if I did Pythag here, guys, if I did -3 squared plus -4 squared equals c squared, c would have to be a positive value. So notice in the 2 triangles, even though the legs have different signs, SIG and S, their hypotenuses are the same. So one thing to note, okay, I'm going to just write this here, all triangles in the XY plane have positive hypotenuses. And it really comes from using Pythag. Once you square things, right, the negatives go away. Okay, so all the triangles here in the XY plane have positive hypotenuses. Okay, let's now see what sine, secant, and tangent of theta are here, though. So if I tried to find sine of theta, sine is opposite over hypotenuse. That would actually be -3 over 5. Interesting. -3 over 5. And you can imagine that cosecant would have the same sign, SIGN. That would just be -5 over 3. If I found secant, that's a reciprocal of cosine. Cosine's -4 over 5, so this would be 5 over negative 4. Doesn't really matter where you put the negative. And then tangent of theta would be opposite leg over adjacent leg. That would be negative 3 over negative 4, which the negatives would cancel out, and I get the same value. So notice that tangent is the same. However, sine and secant have a change in signs, or the positive negativeness of it. Okay, so this one was quadrant 3. The red triangle was quadrant 1. And notice, right, in my points here, both my x and y values were positive, okay, where here my x and y values were negative, right? That's really what led me to having those difference in signs, SIGNS, okay? So let's move on maybe to quadrants, and down below, what quadrants are cosine, sine, and tangent positive? Okay, so let's start with quadrant 1. And we just saw actually in quadrant 1 that my cosine value, cosine of theta, was positive. My sine value was positive. And my tangent value was positive. And it should be recognized that they're reciprocals, that secant, cosecant, and cotangent would all follow the same pattern. So secant would be positive, cosecant would be positive, and tangent would be positive. Okay, but let's go to quadrant 2. Okay, let's go to quadrant 2. And if we think about, I'm going to maybe draw something a little bit over here. If I draw a triangle in quadrant 2, that is a horrible triangle, this point here would have a negative x value and a positive y value. So negative x, positive y, and we know the hypotenuse there, that's supposed to be an h, is going to be always positive. So cosine comes from adjacent over hypotenuse. You would have a negative x over a positive h. Cosine of theta in quadrant 2 would have to be negative, right? Because, right, if I use this triangle over here, cosine of theta would be negative x over positive h. We know h is always positive, so cosine would have to be negative, which means secant would have to be negative. Sine of theta, and if I look back to my triangle, that would be y over h, right? Sine of theta would be y over h. Y is positive in quadrant 2, thus sine of theta must be positive in quadrant 2. So that goes for any angle in quadrant 2, any angle. And then lastly, tangent. Tangent is opposite leg over adjacent leg. That would be y over a negative x. So that would give me a negative tangent value. And again, all the reciprocals are going to follow the same thing. So secant would be negative, cosecant would be positive, and cotangent would be negative. Let's go to quadrant 3. That was the one we were just working with. And what do we see in that triangle above? That my cosine value was negative because my x value was negative. My sine value was negative because my y value was negative. But my tangent value turned out to be positive because it was a negative value over a negative value, so tangent was positive. Okay? And if we go to quadrant 4, let's maybe draw this out. Okay, if I draw a triangle in quadrant 4, there's theta. X will be positive, y will be negative, and the hypotenuse we know always has to be positive. Well, cosine would be x over h, so that would have to be positive. Sine would be negative y over h. Sine of theta would be negative y over h, so that must be negative. And then tangent, which is opposite leg over adjacent leg, would be negative y over x. That would have to be negative. Okay, so there you have your positive and negative signs, okay, for the 4 quadrants, for the 3 trig ratios, and again, you know the reciprocals will follow the same thing. This is uber critically important, much like knowing where the angles were and what quadrants they were in. That was a really important thing, and reference angles are really important. This is also important. There's kind of 3 pieces to the puzzle. This is the 3rd piece. And then tomorrow or in the next class, we'll kind of put all those pieces together. But knowing the angles, knowing the quadrant the angles are in, and knowing whether cosine, sine, or tangent's positive or negative in those quadrants are super critically important, okay? So if you're feeling a little bit unsure of it, maybe rewatch that or make some notes that you can ask in class in our next class. All right, so let's go down here. And all I want you to do, you don't have to tell me any value. All I want you to do is to tell me if cosine of some angle or some trig ratio of some angle is going to be positive or negative. So let's do one together, and then I want you to pause the video in a minute and try a few on your own. But let's start with cosine of 225. Would that cosine value be positive or negative? Well, here's how I would think about it. I would draw a little xy plane. And the first thing I would do is draw the angle 225. Well, hopefully from the last couple days, you know that 225 is in quadrant 3. And if we were to, let me change colors here. If we were to make a little triangle to the nearest, okay, x-axis here, I can make a little right triangle. My triangle's in quadrant 3. Based off of what we just learned about, is cosine going to be positive or negative in quadrant 3? Okay, it's going to be negative. For all the reasons we just talked about before. If I look at that little blue triangle, that's going to be negative, that's going to be positive, and that's going to be positive, right? Because this point down here would be negative x, negative y. Sorry, I screwed that up. That's going to be negative 2. I corrected myself. It'll be negative x, negative y. But cosine would be the negative horizontal leg divided by the hypotenuse, which is positive. So it's negative. I would encourage you now, if you're feeling good about it, to pause, work through B through F, and then hit play and see if you get the same answers I do. If you're feeling a little bit unsure, walk through B with me, and then maybe try pausing. At some point, try pausing and try a few of them. I want you to try that, okay? So tangent of 400. First thing I would do is figure out where's 400. What quadrant is 400 in? 400 is a little bit more than 360. It's 40 degrees more. 400, right, is 360 plus 40. So I went once around the circle and then 40 degrees more. I'm in quadrant 1. We know tangent in quadrant 1 must be positive. Okay. Cosecant of 22 degrees, that should be pretty easy. 22 degrees is in quadrant 1. Okay, quadrant 1, and we know that all 6 trig values in quadrant 1 are positive. Secant of negative 185, that's a little bit of a trickier one. So pay careful attention. Negative 185, the first thing we need to be extra careful about is what quadrant we're in. Negative 185 goes in a clockwise direction, and it's a little bit more than negative 180. So we're going to be in quadrant 3. Secant, okay, mirrors cosine, right? So in quadrant 3. What's wrong with me? Quadrant 2. So secant mirrors cosine. Is cosine positive or negative in quadrant 2? Cosine is negative, so secant must be negative as well. Negative 300, sine of negative 300. Negative 300 is going to be in quadrant 1. Quadrant 1, we know everything is positive, so sine must be positive. And then cotangent of 265. 265 is almost 270, not quite. We're in quadrant 3. In quadrant 3, I know tangent is positive, which must mean cotangent is also positive as well. Okay, so that's a little bit of a preview of some of the stuff we're going to be doing. It's going to get a little bit more complicated than just saying whether it's positive or negative, but if you got that, that's a really good start. Okay, and if you don't, just make some note of that and ask some questions in class tomorrow. Ask your group questions about it, but it is really important you can distinguish what's positive and what's negative depending on the angle. All right, so the last thing I want to do is just work through a couple of examples of a type of problem that you could see. There's a few of them on here that are all pretty similar, so maybe we just do the first one together and then we'll go from there. So number 2 says find the values of the 6 trig functions for angle t if angle t is in standard position and 12, negative 5 is on its terminal side. So here's how I would think about this one, because it's a little bit different. So I'm going to draw actually my XY plane, okay, as should you. And we know I have some angle with a terminal side, and I know a point on that terminal side is positive 12, negative 5. So positive 12, negative 5 would be somewhere in the fourth quadrant, right? 12, negative 5, would you agree? Positive x value, negative y value. And the angle is in standard position. Okay? So when we talk about this, when we talk about angle T, where is angle T located? Angle T, they're really referring to angle T as the reference angle. Okay? So angle T would be right in there. So if that's angle T, I can create a right triangle by dropping down in altitude, meaning, right, that this side of the triangle must be 5, this side of the triangle must be negative 5, and then using Pythag, negative 5 squared plus 12 squared equals c squared. If you know your Pythag triples, you'll know that c is equal to, if you want to pause the video and solve it out, you can. If you just want to watch me, that's fine too. C is 13, right? So there's our triangle. The triangle's in the fourth quadrant. Okay, it's in the fourth quadrant, and I have sides of 12, negative 5, and 13. So let's run through the 6 trig ratios, and if you feel pretty confident, pause the video and see if you can come up with the 6 trig ratios, and then hit play and see if you get the same thing I do. All right, so sine, let's start with the 3 main ones. Sine of t is opposite over hypotenuse, negative 5 over 13. Cosine of t is adjacent over hypotenuse. That would be 12 over 13. You can see once you have the triangle, this is pretty straightforward. And then tangent of t is opposite over adjacent, negative 5 over 12. Let's do the reciprocals. So the reciprocal of sine of t is cosecant of t. So the reciprocal of negative 5 over 13 is 13 over negative 5. Again, it doesn't matter where you put the negative, okay? The ratio would stay the same. Reciprocal of cosine is secant of t. So reciprocal of 12 over 13 is 13 over 12. And then the reciprocal of tangent is cotangent of t. That would be 12 over negative 5. Okay? So for problems 3 through 7, okay, they're all pretty similar. 6 is a little bit trickier. I think you can do that though. 5, same thing. Just remember, if you have any of these fractions that have a radical in the denominator, make sure you rationalize them. Okay, make sure you rationalize them. All right, so for homework, what I want you to do is 4 through 6. Okay, 4 through 6. If you want to do 3 as well, certainly feel free to do 3. You can do 3 as well. So 4, 5, and 6. Oops. The one thing I forgot to mention, I'm just thinking about it now. Let's go back. Let's go back to the first page in the bottom where we had all the quadrants here. Okay, and I just want to give you a little trick to help remember this. Okay, there's this little phrase that says, oops, what happened there? That all students take calculus. And notice that I capitalized all the letters. The first letters, so A, S, T, and C. So when you think about this, the A in all represents that all trig functions are positive in quadrant 1. The S in students, okay, represents that the only positive thing is sine. Well, in cosecant would be, but we're just thinking about the 3 main trig functions. You should know from that the reciprocals would follow the suit. Quadrant 2, the only thing positive is sine. The T in take represents that only tangent is positive in quadrant 3, and then the C in calculus represents that only cosine is positive in 4. So those letters, all student takes calculus, represents the quadrants, 1, 2, 3, 4, counting up like that, right? And then which ones are positive? Okay, which ones are positive? So it's something that is helpful. I use it. A lot of people use it. Sometimes it's abbreviated ASTC. Okay, so you'll see ASTC. That just represents the 4 quadrants. Mr. Aramini texted me the other day, and he was really proud that instead of all students take calculus, given what's going on in the world, it was avoid spreading the coronavirus. A little bit, I don't know, I'm not a huge fan of it, but you know what? If it works for you, it's the same letters. Okay? So that's just a neat little trick or something that might help you remember what's positive and what's negative in each of them, okay? So good luck with that. We'll see you our next class. We'll talk about the homework, and then I've got some work to do. Actually, you know what I might say? I'm going to post the homework solutions, actually. So I still want you to talk about it in your groups, but I'm going to post the homework just so maybe we can, the answers to the homework, so we can maybe speed up reviewing the homework in class, and we can get to our activity. Okay, so check Canvas for the solutions once you've done it. Talk with your group if you have any questions. That way, once we hit class, next time we can spend minimal time on the homework and get to what we have planned that day.